I want to show you this absolute madness you can buy online. Not that you should, but they're kind of like ultra capacitors, but they're called super capacitors, right? So each one of these is 500 farads, right? Let's not bore everyone with the maths. Most people know what a farad is, but let's just very roughly equate it to 500 amps per volt, right? So it's 2.7 volts, which means we get 1,350 amps from each one of these, right? So just call it 15, 3, 4, just very roughly say this potentially could discharge 8,000 amps, right? Even if you're not into physics and electronics, you know how much 8,000 amps is, right? This could start a car. Because the voltage is so low, if you put your fingers across it, I don't think 2.5 volts is enough to discharge. But if you placed, I don't know, like let's just say something, with a resistance where it would just pass through, it would basically weld that thing. That's actually probably how you make welders. And the difference between a battery, makes energy, this just stores it and releases it. So if you release it really quickly, that is insane. I'm going to test this safely. I'm a qualified electrical engineer, so I can test this safely in a proper setting. But that is just amazing, And I think some things a lot of people overlook is electric fields or voltage and current. Current comes first because the best way to think of current is just the flow of electrons. That is all current is. How many electrons, and you know the exact number, flow per second. That's current. 1 amp is flow of electrons per second. Voltage is way harder to get your head around because you can produce voltage from a battery, like from an electrochemical, from chemistry, by putting lithium there. Like the best way for me to think about voltage is voltage comes from atoms. So you have like lithium or some other form of atom. And by pulling those apart, you create like a difference in essentially electrons. At the end of the day, it all comes down to getting electrons across a plate. But the field, the electric field that pushes those electrons is stronger and weaker in some cases. And that is what gives you a more or less voltage. And that nobody ever explained to me. And it took me a long time to get my head around voltage. You can look on like oscilloscopes and stuff and you see that like normally voltage trails the current by a quarter of a wavelength, or you can, put voltage through a capacitor and you can see that actually, you get a field in there. And, in school, they'll tell you it's field lines, draw a line. No one knows what a field is. I've asked, really good physicists what a field is. No one really can tell me properly what a field is. So you've got to picture it for yourself. And, the electron flow is the current, but the field and the charge on every electron is the same, but the field pushing the electron, that's the voltage. And we've got a very, very low voltage here. We've got a very, very low push, but because the current's so high, these will have an internal resistance, so an ESR, so they'll only get maybe 1,000 amps I'd get from that if I was to discharge it, because there's internal resistance in the capacitors. And inside here, there is football pitches or tennis courts of area. That's how you get such high capacitance, right? It's literally just two things. It's the distance between the plates in here, and when I say plate, it's like a foil just wrapped around. And that surface area is massive, and the distance between them. And in here, the distance is nanometers. There's a really clever way of making the gap between the electrolyte. They make it really, really thin. I've waffled on there, but I really wanted to get across voltage and current because, I worked in electronics and electrical engineering for a while, and everyone says volts and current, but no one, I don't think any person I would have asked would say, yeah, the voltage is the field that pushes the electron. It's that simple. It's way simpler than you think. And I don't think anyone knows, unless I'm just way stupider than I give myself credit for, and everyone knows. You tell me.